In this problem, these three circles are touching each other, and this line AB is a tangent line to all these three circles. The radius of the largest circle is 2, and the radius of the smaller circle is 1, and we are supposed to find the radius of the smallest circle. So how to solve this problem? Well, the approach to these kinds of problems is that normally we need to use the given information and try to lead our analysis to Pythagorean theorem and draw some right triangles so that we can find the unknown values in these kind of problems. So the first step that I'm going to take is that I will just show the center of each circle, and then I will connect the center of this circle to the smaller one, so the largest one to the smaller one. Similarly, I will connect the green color circle center to the smallest one. So now I can easily see that I can draw two right triangles. This is one, and this is the other one. So what I will do is I will try to find the value of this line segment, which is from the center of blue circle to the center of pink circle. The radius of blue circle is 2, but the radius of pink circle, we don't know it. So let's call it R, since we don't know it. So from the center of blue circle to the center of pink circle will be equal to 2 plus R. And similarly, the same thing happens here to the circle, a green color circle. So again, the distance from center to center will be equal to 1 plus R, right? And what else I can do is I will try to make my triangle. So I will try to draw it down till here, and then draw a straight line from the center of the pink color circle to intersect this line coming from the center of the blue circle. And similarly, the same thing here I will do. So then I will try to guess the magnitude of the size of this side of a triangle. So here, if I look carefully, I will see the radius of the circle again is 2, yeah, 2 units. But something has been deducted from this 2 unit, and that is equal to the radius of the smallest circle, pink color circle. So we can just say the magnitude of this side is 2 minus R. And similarly, the same thing happens here. So the magnitude of this side is again 1 minus R. Yeah? Okay. Now I can try to find the value of the unknown side, and that is here. So let me call it X. And the other side, which is from the center of the pink color to this part of this green color circle. So we call this part X prime. I will try to find the values of these two right triangles, and then I will see what it will lead me to. So Here x is equal to, I will use the Pythagorean theorem. So x will be equal to, so the size of this side, which is 2 plus r, 2 plus r to the power of 2, minus this side, 2 minus r to the power of 2. And to remind the Pythagorean theorem is like in a right triangle. Okay, if it is CAB, then therefore B will be equal to square root of C to the power of 2 minus A to the power of 2. This is what we are doing right now here. So this is the value of x, and at the same time I would like to along with this calculation find the value of x prime, which is equal to, again, the same approach. It will be 1 plus r to the power of 2 minus 1 minus r, which 1 here to the power of 2, which 1 here is the radius of the green circle. So I just try to simplify and find x and x prime. So if I simplify this one, let's go to the first calculus. So let me say first, this is the second one. So x will be equal to, I will just expand, and it will be equal to 4 plus r2 plus 4r, okay, minus 4 plus r to the power of 2 plus, minus 4r. So similarly, the same thing happens here. X prime will be equal to, we will expand again here, 1 plus r to the power of 2 plus 2r minus, I will keep the parentheses here, it will be 1 plus r to the power of 2 minus 2r. Now I will try to simplify, and I will reach this minus 4 will be cancel out with this, and then r2 with this r2, and then minus 4r will be 8, positive 8r. So x will be equal to 8r, which I can simplify it again further, and I can get it like 2 square root of 2r. So let's now move on to x prime. X prime will be similarly equal to, again, the same thing happens here. This r2 will be cancelled out with this r2, and this 1 with this 1, and then we will be left with the 2r plus 2r, which will be equal to, so let me erase this one, it's too long, 4r, which I can simplify it further. I can get it 2 square root of r. Now what I will do is, if I add x plus x prime, I can find the length of this line segment, which I'm coloring it now with a red color now, from here to here. So I can find the length of this side. So let's do it. So if I add x plus x prime will be equal to 2 square root of 2r, and this r is below radical, plus 2 square root r. And now I will try to simplify it further, and I will factorize the common factor here, which is in both, exists in both parts. So let's see, square root of r is common in both, and also 2 is common in both. So let's just factorize from 2 square root of, sorry, 2 square root of r. I can factorize, and then I will be left with the first term, which is square root of 2, okay, because if I multiply it, I will get the same thing. And for the second term, 2 square root, so it will be 1, yeah, because if I multiply it by 1, I will get the same term here. So now I am done with the size of this line segment, which starts from just above the tangent line within the blue circle and within the ends in the green circle. Now what else I can do? I can also use the information that I have and I'm given. So one more line I can draw here, and that is the line that connects the center of the blue to the blue circle to the center of the green circle. So I will draw this line, and well, the size of this line is the radius of the blue plus the radius of green circle, and the magnitude is 3. So now I can see that I can draw a different another right triangle, and if I keep going until here, this will be the radius of this circle, which is still 1, and I can get connect from this side to the center of the blue circle, and then I will notice that this will be a right triangle, and because of course the radius of this green circle is the half of the blue circle. It means that the diameter of the green circle is equal to the radius of the blue circle. That's why if I draw the tangent line from the upper part of this green circle to the center of the blue circle, it will be 100% horizontal. And then I can get the right triangle here, 90 degree. So I know these two sides. Now, if I look carefully, I will realize that the magnitude of this line that I already calculated is equal to here, all right? So I will write it above there. The magnitude that I found was 2 square root r times square root 2 plus 1. Yep. So okay, now we are almost there. So we are almost done, because again I can use the rule of Pythagorean here in the new right triangle that I just drew, and I can find the value of r simply. And how I will do that, I will just say this value that I wrote there is equal to 3 to the power of 2 minus 1 to the power of 2, based on the Pythagorean theorem. Is the same as I am talking about this right triangle right there, which suppose this is C A B, okay, and then now I am trying to find the value of B. B is equal to C to the power of 2 minus A to the power of 2. Okay, the same story here. Now I will try to find the value of r from this new equation that I have found. So let me write it down below this calculation here. Let me write it below this calculation here, and it will be equal to 2 square root of r times square root of 2 plus 1 is equal to 3 to the power of 2 minus 1 to the power of 2, and it will be equal to square root of 8. And now I can conclude that square root of r, I need to divide this side of the equation by the coefficient of the r. So therefore I will go ahead and I will write the square root of r will be equal to square root of 8 divided by 2. So I should write this 2 times square root of 2 plus 1. And I can also simplify it further, so square root of 8 will be equal to square root of 2 divided by 2 square root of 2 plus 2. Now I will try to rationalize this fraction, and if I rationalize this fraction, I will write it again here. 2 square root of 2 divided by 2 square root of 2 plus 2, and I will multiply this by 2 square root of 2 minus 2, 2 square root of 2 minus 2, which will be equal to 4 times 2 minus 4 times square root of 2 divided by 4 times 2 minus 4, which this will be equal to 8 minus 4 will be equal to 4. So let's again simplify it. 8 minus 4 square root of 2 divided by 4, which eventually be equal to 2 minus square root of 2. But now, this is the value of square root of r. So therefore, square root of r is equal to 2 minus square root of 2. But we need to find the value of r. So therefore, we will raise both sides to the power of 2. So we just simply raise both sides of this equation to the power of 2. And then I will get r is equal to, so just expand this parenthesis, 4 minus 4 square root of 2 and plus 2, which I will get is equal to 6 minus 4 square root of 2. Therefore, the value of r, which is the radius of the smallest circle there, is equal to 6 minus 4 square root of 2.